Hi there, my name is Tim Middleton. I'm a member of the Oracle Coherence development team. Welcome to this screencast on an introduction to persistence, a new feature available in Coherence 12.2.1. Today we'll give you an introduction to what persistence is. We'll talk about some architecture and topologies. We'll have a look at some configuration, tooling, and then finish off with the demonstration. In 12.2.1, the new persistence feature provides durable storage of your cache data and associated metadata. This means that data will not be lost on scheduled or unexpected shutdown of a Coherence cluster. On cluster startup, the persisted data is automatically recovered and the caches are populated with the data and metadata present at the time of shutdown. In previous versions, you would have had to manually warm the caches from a database or other location. Persistence provides the ability to create a point-in-time snapshot of caches for backup or transfer, say from production to a QA environment. These snapshots can then be archived to a central location or recovered using various tools to revert caches or services to a known state. As well as cache data, various metadata is also persisted, including index definitions, locks, listeners, and triggers. A number of storage topologies are also available, including local storage and shared storage, depending upon user requirements. Coherence transparently persists data to disk without any additional code required from the developer. There are two persistence modes available. Active persistence is where all data is persisted to disk in the same atomic operation as primary data and backups to another member. The clients only receive a response when both operations are complete. On-demand mode is where data is not persisted in real time, but a snapshot of the current data can be created on disk and recovered at any time as required. This is enabled out of the box for all partitioned and federated services. You can also create and recover snapshots while running in active mode. The first storage topology is where all members persist their data to a centralized shared file system. In this case, all members can see all partitions, and as such, multiple simultaneous machine or node failures can be tolerated without data loss. With locally mounted file systems, or local storage, each member persists data locally and can take advantage of local resources such as solid-state disks. This allows for very low persistence latencies. On-demand persistence is enabled out of the box, but active persistence can be easily enabled by adding the following element to a distributed or federated scheme. The above uses default persistence directories, and these directories and other options can be configured in the override file or via system properties. It is also possible to turn on active persistence for all services and caches by specifying the following property: Coherence distributed persistence mode equals active. The following set of tools are also available to allow users to interact with the persistence features introduced in 12.2.1. Using a standard JMX connection from any tool, the Persistence Coordinator MB in primitive operations such as create snapshot, recover snapshot, etc. can be issued against services. The Coherence JVisualVM plugin provides capabilities in the new Persistence tab for easily executing the operations and monitoring persisted related MBs. It also provides some graphs to view information over time. CoQL or Coherence Query Language provides commands for issuing all snapshot operations and can be scripted for ease of use or batch operations. There's also support for issuing commands via WST when using Coherence in a managed environment. We'll now go through a demonstration where I'll start up a cluster with the default persistence mode of on-demand. I'll work with snapshots and caches. I'll then restart the cluster and configure active persistence mode, and during this time we'll be using the JVisualVM plugin and console. Okay, what I'm going to do is start up a cache server using the out-of-the-box scripts, and I'm going to specify a -JMX option so we can connect via JVisualVM. Using the scripts, by default, we'll get on-demand persistence mode. So I've started that up. Let's start JVisualVM. I'll connect through to default cache server. Once we've got the VisualVM plugin installed, when we connect to the Coherence MBean server process, we will get a Coherence tab. You see the Coherence tab, and now in 12.2.1 we can see the new persistence tab. So under here it shows us a couple of things. It shows us the list of services in their persistence mode, so by default on demand, plus some other information that's relevant when we're using active mode. Also, we see notifications, so when any operations are carried out, we'll see the JMX notifications here. So what I'm going to do now is I'm going to start up, create a cache, so run the Coherence console. So a cache called test. So we can see now, by default, we can see it's on demand, and there's a default directory where it's going to store our snapshots. So I'm going to put some data in. So let's go back to the Visual VM plugin, and we should see when this refreshes that we've got our 100,000 objects in. So 100,000 objects. What I'm going to do now is I'm going to right click on this service and issue the operations. So these are the operations can issue against them. So at the moment I'm going to go create snapshot, and we'll call the snapshot 100. What this does, it creates a snapshot of the contents of that service and all the caches in it that are defined. So we can see it successfully created the snapshot. If I go back to the console now, we can see that the service has automatically been suspended and resumed. This is done so that you get a consistent view of the data when you create a snapshot. So if we look at that, we've got 100,000 still there. So if I clear that, and we see the size is back to 0, if I go back into here, I can recover that snapshot. So I can say I want to recover snapshot 100 for this service. And what that means is it will recover that snapshot and replace the contents of this cache, the service and the cache, with the contents of that snapshot. So it's successfully recovered that. And we look at size, and we can now see we've recovered the data in. If I then did a clear, I could actually create a new snapshot. So let's create a new snapshot called empty. If I right click on here and say list snapshots, we can see we've got 2 snapshots. So I've now got an empty snapshot and a 100 snapshot. So I could remove the snapshot as well. So remove snapshot. I don't need the empty snapshot. And that's been removed now. What I'm going to do now is change from on-demand mode to active mode. So let's exit out of this. I'm going to shut down cache service, Visual VM. What I'm going to do is I'm going to use the quick way, which is to set up the option here. So the system parameter Coherence distributed persistence mode is active, and that means it'll apply to all partitioned and federated caches. I'm going to start up the cache server and -JMX mode. If this is the first time we start up in active mode, then we'll effectively have an empty set of active data. Let's have a look. If we look in the Persistence tab, we can see it's now active mode, and we can see now that the total active space is being tracked, and we can see that how much data is on disk and any other statistics we would like here. So what I'm going to do now is I'm going to start up Coherence console, select our cache, and we can now see the mode is active, and this is where the active data is going to be stored. So if I then put in bulk, put 100,000, as that's being put in, we'll see that the total active space used increases. So we can see now that it's using active persistence. And we can see there's 100,000 objects. Now what we can do, when we've got active mode, we can still issue snapshots and recover snapshots. But the key thing about active mode is if the cluster is shut down due to unexpected or planned maintenance, then the active data will be recovered. So if I jump out of here, shut the cache servers down. Both shut down, so I'm going to start them up. If I then go into Visual VM and connect back to those processes, go into Oracle Coherence, Persistence, it's back up and running, and we can see once it finishes refreshing, then there's 100,000 objects. So what's happened is it's started up and it's detected you're running in active persistence mode, so it's automatically recovered that data off disk and it's all ready to be worked with. So if I go back to here, I can start up my Coherence console and I can see that the size is 100,000. So I could now create snapshots and carry on, but this allows us to then very quickly and very easily recover data. The other thing I wanted to quickly show you was that you can actually recover metadata as well. So what's included in metadata is locks, listeners, triggers, and indexes. What I'm going to show you is an example if we had a client running who registered a map listener and then the cluster shut down and restarted, we can still have that map listener being active. So within here I can say I want to listen on key 1. And what that means is that if I open up another session here, if I put a value into 1, we go back to here, we can see that there's a new value. Okay, so the map listener has been registered. And if we look in here and look at the case storage details, we can see that there's a listener registration. So what we can do, if I jump out of here, we can simulate that the clients are still running, but for some reason the cluster got shut down. Okay, some sort of hardware fault perhaps. We restart it up and it will recover the data. So wait for it to recover. And this client here is the one with the listener. So it's joined again. Same again. If I then did a put of 1 and a new value 2, we can see here that even after a cluster restart, the listener is re-registered because it's been recovered from active persistence and the client is still available. Hopefully this has given you a good introduction to persistence. There is more information available on the links on this screen. An additional screencast is also available which goes into more advanced topics. Thank you very much for your time.